YouTube, this will be the third trip to Ken's shop. And in this trip, what we're going to do is put the block in a machine that will deck it. We make it true to the crankshaft, and we'll show you how we do that. And then we're going to take it out of that machine and put it in a boring machine and finish boring out the 8th cylinder. So here we go.
Okay, so Glenn and I balanced this. This is a one-piece rear main seal, 4340 steel crank from Scat. The manufacturer manufactures these to be internally balanced, meaning all the weight is on the front was to the right or to the left in the back. There's no weight out here. They call this a plane. There's a plane here where it's rotating, so we have no external mass there. Glenn was able to reuse his balancer because Summit was kind enough, when they manufactured their balancers, they made a removable weight. So that's the weight in there, that's for an external one, and that's what the original crank was. So what we did was we already had this balance. We said, well, why don't we check it? We'll take the weight out, we'll throw the balancer on, spun it, and you can see it really came right into our industry tolerance standard, 1.37 grams on the back, 1.51 on the front. So pretty small amount. I was pretty happy with that. We did put a plug in here. Glenn had brought up to my attention, what about the hole that the screw? If you look, they're internally balanced is the same balancer, and it's tapped and drilled for that weight, as you can see right there. I did put a set screw in there just thinking it might help. I didn't do it without it, but I think it doesn't really matter. I think you're probably only chasing like maybe 1 gram when you're that small, the radius. So we figured it'd probably be something nice to show. That just unbolts, so if anybody has a Summit balancer, I would recommend. I mean, they're really nice for the money. It's funny, Glenn had one, I had one here, I was gonna sell them, and then he says, well, it's removable, so I said, bring it and let's check it. We'll just throw it back on the balancer and make sure we're good. So I'm gonna spin it real quick. It'll simulate so you can see. I don't know if we did a balancing. Did we do balancing?
Yes, sir.
We did. We're gonna do it one more time. This is gonna bring it up to 500 RPMs. If you watch up, here's a little tack. It says I'm doing a safety check. Yep, I passed, I'm not out of balance. And now I'm gonna get up to 550 RPMs, boom. It's gonna start collecting data. So you can see it says acquiring data. And now it's gonna hold it, and it's looking for vibration on those transducers on those 2 planes. And it knows from the tack exactly where everything is from the pulse. There's an encoder on here. So it knows out of 360 degrees where it is. And there you go. 1.36 grams, 1.33 grams. So we're almost exactly the same on both ends. And you see it says intolerance. It doesn't even give you where that is anymore because it's so small. So that's that. We figured that'd be a nice little brief, I don't know, synopsis of why we did this and what we're able to do. So if anybody has an issue, I would feel confident you could probably swap that balancer out without balancing it on an existing one and go either way. So
to sum up what we just said.
So yeah, Glenn was explaining it. This allows you to, if you have an externally balanced like he did, already bought the balancer. I think they're like maybe $100, $200, somewhere around there. They're kind enough to make it removable, which is great. And as you can see, it came right in. It didn't throw it out of balance. Glenn had a concern. I said, well, let's balance it and let's just make sure everything's fine.
When you put cam bearings in,
yep.
Is the one furthest in smaller than the next one? How do you put them in? How do you get it beyond?
So the journals are all the same.
Okay.
On a Chevy. Small block and
so
big
you got to press it through all the journals to get to the back one?
Nope, you can go from either end.
Okay.
Yep, so what you can do is you can drop it in. Like on a big block Chevy, you can, or a small block, you drop it into that cavity.
Okay.
Either side of the main where you want to be.
All right.
We're going to do, when we do yours, you'll be able to see that better.
All right.
Okay, we're here at the boring bar stand. And what we're going to do is we're going to rough bore this. This block is a 454. Starts out at a 4.25 bore, 4 1/4. We're gonna go 30 over. We're gonna leave 10 thousandths in it to hone, so we're only machining 20 thousandths out with the boring bar. The 10 we leave in there so that you can hone it, and if there's any distortion from the torque plate, it'll true up and you'll get all that distortion out of there. Prior to this, I did deck this block. For filming purposes, I did both sides, but I left 5 thousandths on the one side so that we could set it up after this and walk through the whole process of decking a block using a BHJ fixture. So right now we're gonna come in, we're gonna pick up this cylinder, we're gonna set the tool bit, and then we're gonna bore out. I think I left 3 or 4 thousandths in this for us to clean up just so we could walk through in the film. So that's what we're gonna start with first. This is the bit we're using. It's a solid carbide. It's got, you know, like probably 3 different angles on it so that it's a low pressure, and it cuts really nice. You can see the finish it leaves. It's a pretty nice finish for a 4-inch 280 bore. So first thing we're going to do is we're going to set this. Well, before we even do that, what we're going to do is we're going to come down, and this boring bar, I'm going to loosen it up. It floats on this table, as you can see, and then there's 3 pins. So these 3 pins extend out and pick up the cylinder. And what that does is that centers the bore to the boring bar to the cylinder. What we're going to do is we're going to bring it down and we're going to go through the centering process. I have a gauge that I made that allows me to check the run out, because what I did find is sometimes this could touch and it might be off and you'll bore like an eccentric. So to eliminate that, I always check with a gauge now. So we'll bring this over, bring it down in here. Hang on, I got another light, it might help. And then what you do is this little wheel up here runs through this boring bar, and it has a tapered shoe, and it's going to extend those 3 pins out till they pick up on the cylinder. So right now they're snug on the cylinder, they extend it out, and what I do is I turn this to make sure it's not bound. And then if that's good, I'm going to turn this, and there's a clamp in here. Right here, there's a clamp that's going to clamp this to the table. And that's about as tight as it needs to be. We'll loosen this up. We're going to turn this on. We're going to back feed it out. And now we're going to check the run out. So this little gauge is going to go in place of the tool, and then it'll touch the bar, the hole, and then we'll be able to see the run out. Well, this is a little clamp in here. Bring it down. And we're just going to set this. I really don't care what the size is. I'm just checking run out. So we'll just put it close to whatever. It looks like it's close to the 10. If you can see the 10 right there. Basically, I'm going to rotate this around.
Where's the 10? Oh, way
right
down there.
Yeah. See if you can get in there, Glenn. That's where I need a laser pointer.
Right there. That's the best I can do.
Yep, so we're just going to check run out. So if you want to stay there, Glenn, I'll turn this. So there's 90 degrees. We're still at 10, right? And we'll go another 90.
The gauge turned.
We're a little bit shifted. So we gave up about 3. And right there, about 3. So I'm going to loosen this up. We're going to just knock it around, because I'd like to get it pretty close to 0 run out. Let's see here. I think I gotta go this way. a little bit. Oop. Pretty sensitive, so give me a minute and we'll get there. Okay, pretty good. About 5/10 TIR.
Does it move when you tighten it?
We'll check it. Looks good. Looks good. Looks good, Glenn.
Good.
Let's bring this up. We'll put the tool in. It's got a little spring-loaded thing and a positive stop. This is the setting micrometer we use. It basically detents and locks in, gives you a face on here. It's all calibrated so that the graduations match up. We're gonna go just a couple thou right there. And now this is gonna go in. You can hear it click in there, and then that's going to stop right there. And now I'll lock this shoe in. And that's that. Now we're going to bring it down. Spindle go. Kick in the feed. It's a very light cut. I only take 20 thousandths off when I do my boring, so 15 to 20. It's an old machine, I don't want to beat on it too much. So as you can see, it's feeding down right now. It's at a slow rate. So you can understand how this boring bar works in this stand. Basically, this stand is ground parallel, and the block is decked with a BHJ fixture, so we know we're boring perpendicular to the deck. I could be off on center to the original bore. I don't have instrumentation here or a fixture to pick up that. BHJ makes fixtures that go on the dowels, and they set up and give you a reference, and you can offset board if you had to. I don't have any of that stuff, unfortunately. We work off the old position. Sometimes I can offset bore this. Say there was a rust spot or something on an old block. We can shift the bore over so that it cleans the machines more off of where that rust spot is and try to save the cylinder.
Mm-hmm. Do you sleeve cylinders?
Yes, I do. I'll grab a sleeve. You can see what they look like. Melling makes these sleeves. The OD is ground. It's got a rust preventer on there. They chamfer this, and they're rough turned on the inside. You can see how coarse that is. And what we'll do is, if a block is too rusty or is blown up or has a crack, you can bore it out, press this sleeve in. I usually shrink them in with liquid nitrogen. I'll get a dewar of it from the local welding supply. Put these in, shrink them. Usually I have a 2-thou press on these, and they'll drop right in.
All right.
And then we'll cut down the length and then rebore it and hopefully blend it in on the bottom, and you won't even know it's in there. So it's done spinning. As you can see, it reached the bottom of the cylinder. It's going to return up. And there we go.
Now you don't get any cross cut when you do that?
Sometimes there's a little bit of a line where it comes up, but I left 10 thou in there, so.
Okay, that's right, you're gonna hone it.
Yeah. I mean, you can look.
I was asking more for the camera.
Actually, very rarely do I leave a drag mark.
Yeah.
It's really that good. Okay. Okay. All right, let's get a hook and. Okay, let's put the BHJ fixture in. We'll talk a little bit about that. 2-inch bar.
Holy smoke.
Yep, solid steel. This is going to set our datum. So this was already line honed. So this should go right through here.
Now you have the caps torqued?
Yep. Yeah, I left everything in there. How's that?
That's nice.
Pretty nice, huh? So that's why we line honed it first. We know now that the center line's not like this. It's a nice straight line. Our fixture's gonna go in. It's gonna give us a 90-degree reference. And then I'll explain a little bit more about how the machine knows where it is and what it's parallel to. So this fixture's got to be 35 years old, maybe older. Matt and I bought this from, or actually Matt bought this before I even started working for him. He had this. So that was easy 35 years ago. If you look on here, let me wipe it off. 7.600, so that distance is from the center line of this bore to this face. These are both 90 degrees to each other, so they give you a reference. And then it works off the center line of the crank and the center line of the cam. And that's how we know where we are. Is there some stack up? I'm sure there is, but it's well within the tolerances. So that goes on like that. That establishes our position because you don't really have a reference. We're going to use this plate as our reference. And then everything we work off of is from the center line of this bar. So what we're going to do real quick, I can't remember which one I left stock on, so we're going to measure it real quick. Just stand it up here. That looks pretty good. Okay, we're gonna measure down to this. So this is just a ground bar with our depth mic in there. It's a 1/2 inch, it's ground a 1/2 inch so we can compensate for it. So we are right there. 20. So this is the side we got to cut because I know I went to 15 on this one. Let me check. So usually I put that right on the center cylinder. Just hold it down, touch off. Yep, we're right at 15. So this side has 5 on it still. Right there. Pretty much 5. So we're going to take 5 off of this side. I'll show you how we true it up. And then after that, it'll be ready to get honed with torque plates.
All right. Getting close.
Oh yeah, getting real close. Okay. Okay. So this bar sits in 2 saddles, And what we do is we tram that bar in to make sure it's parallel to these ways. And I'll show you how we do that. And this is adjustable. This end can go up and down. That's how you make it parallel to the ways. The head in here is already parallel to this. When we set this up, we'll grind or we'll cut something, measure to this, and then we set it to that so we know we're parallel. You're probably going to say, well, how do you know what the height is? So we know that this is 7.6, so we can do the math. And we'll measure the rod length, the compression height of the piston, and the stroke will be half. These clamps just go in, they clamp this tight. Can't go anywhere. This machine's pretty old. It's been around, I think it was 1970. So we refurbed it a few times in the last 40 some years that we've had it, 35, 6 years, whatever it's been.
Been around as long as I've been around.
Yeah, we used to call it the Maid of the Mist because it was a wet grinder. And if you've ever been on the Maid of the Mist, you know what that's like. Now it's a CBN mill with a variable feed, which works great. I just keep a little tension on this just so the block never can lift. Now we're going to tram it in. So what we're going to do first is we're going to tram this bar in. We're going to make sure that it's level and parallel. Let's say parallel to this, not level. So we can bring the feet up. This bar has been ground several times. We always have it sent out and inspected. My friend Paul Francia had it done the last time for us. A little higher. All right, let me get the indicator. Okay, it's not a laser mic. It's as old as this machine. I like it. It's kind of retro. It's got a Federal gauge on it that still works pretty good. So all we're going to do is we're going to take a reference where that bar is. I don't really care where it is. I just want to make sure it's the same on both sides. So we'll call that 0. Put that in there. So pretty close. That's pretty much 0 right there. You get that, Glenn?
That way. Yeah, I see it.
So that's telling me that bar is level, or I'm sorry, parallel to this plane. So if you look at the top of this is the plane, and now the crank shaft is parallel to this end to end. Now what we're going to do is we're going to tram it in this way. We're going to use our plate. This is going to be our plane that we're going to measure here for rotation. So we'll bring it back down a little bit. Ooh, let me get that up there. I'm just going to bring this down. I don't really care where the measurement is. We're looking for run out. So that's pretty good. Just got lucky. It's sitting in the same spot that I had done it before. So that's pretty good. I mean, you're talking maybe a couple tenths. There's a little bit of a crown there, but that's pretty good. So I think we're good there. So we know now that we're perpendicular and parallel. So now you can machine this and you know that's going to be parallel to the crankshaft, and both deck surfaces are going to be the same height and not like this, like a skewed angle or a skewed angle this way. So we have another gauge over here we're just going to use. It's a zeroing gauge I made. We'll just bring this up. This gives me a reference of where the wheel is.
The cutter.
The cutter. So every time I change the cutter bit, I re-zero this. And this gives me a little safety factor so I know where the tool is. So 0, we'll use this to check real quick. So I think we're gonna just adjust the run out a little bit. We're close to where we were, but just a thou here will make a difference. That's so damn close. We're going to take 5 off. Let me just bring this one up a little. Try that. That looks pretty good. Let's go back to our 0 gauge. 0. Pretty close to 0 there. So we're within a thou total over, I don't know, what is that, 28 inches? We're going to take 5 off of this so I could chase it, but I think we're okay. We're well within our tolerance zone. So we're going to be a little safe. We're going to blue this so we can kind of see where it cuts.
Where does blueprinting come from?
So blueprinting comes from basically re-engineering this. Basically, these blocks are manufactured to an OEM specification that the engineers at General Motors, whoever, use for a tolerance. Their tolerances are a lot bigger than the tolerances we use in the racing industry. They're mass producing them. So these deck heights that we're setting could be 25, 30 thousandths end-to-end difference, over exaggerated. I've seen them. They could be
From OEM.
5 degrees off, whatever their tolerances are. All we're doing is we're taking it back to, we know what 0 is, and we're going to say instead of a 30 thousandths tolerance, we're going to move everything down to maybe a plus or minus a thou or 2 thou. Okay. And that allows you, so the blueprint comes from, you're looking at the print, if you had a drawing of this, and we're basically shifting all the tolerance down since we have the time available to do that with the equipment. And that's pretty much what we do with decking and line honing. If you remember when we line honed, we worked backwards and measured the oil clearance with the crank so we could tailor it plus or minus a couple of tenths to get the vertical oil clearance we wanted. The OEMs, when they do it, they have a wider tolerance, but still it's only a plus or minus, it's only a thou tolerance total. And you'll see sometimes they might have over and undersized bearings from the factory, and they'll do them in batches. So say they machine 1,000 blocks and maybe they cut on the high end, they would compensate with an offset bearing that has a little bit more material on it to tighten the clearance up.
An X bearing. Yep,
it could be an X or it could be a minus. Also, because they're working in the tolerance of the crankshaft, the bearing, and the block, and so are we. So when you add all those up, if everything has a little bit of tolerance, you could be on the high end of a stack up or on a low end of the stack up. So that allows them some manufacturability so they don't have to scrap something. They'll tailor it 5/10 either way. We kind of do the same thing here, at least I do. I think most engine builders do today. It all starts with the line hone. I guess that's why every block we do gets line honed and vertical oil clearance is set.
That's the only way you can get it square, right?
Yep, and then once we do that, this old BHJ fixture, we have, I have a whole drawer of donuts. I don't know, there must be 50 sets of different donuts to fit the bores. So that's kind of what we're gonna do. So now we're just gonna blue this just so we can kind of see it. We're gonna take off 5. I'm gonna back it down a little bit just to be safe by 5. Let me get the bluing. Okay, so we're right at 18. We got to get to 15, so we're going to take another 3 off. What I usually do is I'll use my indicator just to know it should correspond with that. Okay. Slow the feed rate down a little bit, and we should be good. So we're right at 15 thousandths on the depth mic. So that's, if you did all the math, that's where we needed to be. So both sides are the same, and we know they're going to be good end to end because the block is parallel to the thing. So, all right, that was successful. I'm glad we did it that way. It was a little quicker.
Well, I hope you enjoyed that visit. We do have more to do, so there will be more.